Okay, so let's solve this determinant, which we created as a definition to the crossing of A cross B. So a method we're going to use here is called the cofactor method. And it's probably the easiest way to do this. What we're going to do is rewrite that a number of times. So I rewrote the determinant down here from above. And what we're going to do is we're going to select a value. Now for this demonstration, I'm just going to end up selecting I, J, and K. But you can really select any value in here, and sometimes it's easier to solve your determinant depending on how you do that. But so let's start out by figuring out for I what this is going to result. So the reason you do this is you then cross out these other terms here in this, and you create a cofactor, and you multiply that by the determinant of the minor matrix. Okay, so in this case, our minor matrix that got created is this matrix, and we will need to find and solving the determinant for a 2 by 2 is a pretty simple process. We'll go through that. So our first term here then that we're going to get is the I term. It'll end up being the I term since I chose this here. Cross this out, created this minor. So our cofactor is going to end up being positive I. And then I'm going to multiply that by the determinant of this matrix, which is AYBZ minus AZBY. That's just by the definition of that. Okay, so now I'm going to select this J term and cross out these values. So cross everything else out in this row, and then one column. It won't be this column actually. It will be this column. Since I chose J, this column was chosen because I chose I up here, so we have to go to the middle column since I chose J. So this is going to get me my J term. So this equals, now this is going to end up being a negative J. And again, these are called cofactors. That's what they end up turning out to be. And I will just talk about them a second here. So now you do the same thing. So now our minor matrix is AX, AZ, BX, BZ. So we just solve the determinant of that matrix, which is AX, BZ. You just take this times that, and then you subtract off BX times AZ, or you could swap those around, AZ times BX. Doesn't matter. And that is our J term. So for our K term, we finally select the last one in the row, cross these out, cross those out. We have a minor of AX, AY, BX, BY. And in this one, now we're going to add again. Back to adding K times AX, BY minus AY, BX. Okay, so when we finish up here, you see what we end up with is we're going to end up with something when we finish the product of these and then subtract it from the product of those coefficients. We're going to get one value, and that's going to be our I term. We're going to get one value here. It's going to be our J term, and oops, let's write it the same way I did this one. So you got your chunk in there, and the j term plus whatever's left, k term. Now, one thing that I wanted to point out here is that you don't need to use this top line to pick the top line. You can pick any row or column you choose. It actually is better to not pick the top row because I, j, and k are always going to be here, whereas some of these coefficients, ax, ay, az, bx, by, bz, might be equal to 0. And if that's the case, you can really shortcut the process by choosing a different row and column to cross out. So you can choose either one full column or one full row. So look back in your high school algebra, trigonometry, at matrices and determinants, and if you're having trouble making heads or tails out what I'm saying, I'll do a problem that demonstrates that actually as an example. There's another way, but I'm going to show it here as another approach. But this approach always requires you to do all the work, and this approach though is probably easy to remember for most of you. So let's start with our determinant again, and in this approach what you need to do is you need to rewrite, well, we're going with orange now, you need to rewrite this. I wanted to go with a different color. The first two columns you need to kind of write again over here. So this will be ax, ay. You want to try to keep this as neat as possible because it's easy to screw up the... And now what you want to do here is you want to find some color that doesn't, it's not so oppressive. I guess it really isn't any. We'll use the pencil. So now you want to take and multiply these three terms down this diagonal, multiply these three terms, and multiply these three terms. So let me do that. So like this, notice I got an AYBZI plus an AZ times BZJ plus an AXBYK. That'll end up giving you the positive terms like we can get from above. Okay, next you want to then take and subtract. Here's where we can get into some difficulty. Subtract these, all these diagonals. Let me make them yellow. So we want to subtract the yellow now, the product of the yellow diagonals. So minus, so here's all your 6 of your terms, and you'll find that these are the same as the 6 terms you're going to end up with up here. So you can cross-reference all that stuff yourself and double check. Okay, so as a final note, if you're going to use the cofactor method, remember this matrix. Let's just call it REM for remember. Doesn't really mean anything, but 1 minus 1, 1, minus 1, 1, minus 1, 1, minus 1, 1. This is the negative sign, how the negative sign works based on what you are going to use in your cofactor. So for example, since we chose I here, J and K, we're actually going totally along this top line up here. And the reason this is a plus I is because this is a plus 1. And the reason this is a minus J is because this is a minus 1. And then going down further, this is a positive K, the cofactor down here, because this is a plus 1. So you got to remember this little matrix, because if you choose a different row, you're going to have different cofactor signs depending on that. You can also choose to do a column. We could select, for example, if you look up here, we could select to go down along this column here, and we would start out with J at -1, minus J as our cofactor. Then we'd have positive AY, and then we'd have negative BY. And of course, the minor matrix, when we started out with J, we would eliminate this, and we'd have AX times BZ minus BX times ZZ times our J term, which again is -1. No matter how you do it, though, you're going to end up with exactly the same results. So you might want to play around with solving matrices. I'm going to play around with deleting this so it's not here in the notes. That's about all I have here.